All right, Mr. Ahmed here for Unit 7. Today we're going to start up working with our polygons, and the first thing we're going to do is 7.1. In 7.1, we're going to work on interior angle measures of polygons. Just a brief reminder, a polygon is a straight-edged, closed figure, so none of the edges are curved. All of our sides are straight, and we've already kind of seen quite a few of these. Some of these terms are going to be pretty review for most of you, and we are going to really work on the angles of these polygons. Most specifically today, the interior angles. So this little chart here is an investigation for us to determine how we can figure out the number of degrees or the measure of degrees for the interior angles of polygons. So the first one's a triangle. And as we know, a triangle has three sides, and there's only one triangle that can be formed out of a triangle. And the sum of its interior angles is always 180 degrees. We've already discussed that. So our next figure is a quadrilateral, which is a four-sided figure. And what we're going to do here is we're going to break this figure apart into triangles to figure out the sum of its interior angles. So for us to break it apart into triangles, we're only going to draw it from one vertice. So I have now broken apart this quadrilateral into two triangles. So there's two triangles inside of it. And if there's two triangles inside of it, we know the sum of these angles for the first triangle is 180. And we also know the sum of the angles of the second triangle is 180. So 180 times 2 is 360 degrees. So the four angles of a quadrilateral have to add up to 360 degrees, which you might have already known that. Now, a pentagon, I would doubt we probably have discussed the sum of its interior angles. So one other piece I guess I should bring up is the number of sides is the same as the number of angles. So if I have a pentagon, I have 5 sides. I also have 5 angles. So we're going to break it apart into triangles as well. So just picking a random vertex, I'm going to use this one. I can break it apart into 1 triangle, 2 triangles, and 3. And that's going to divide all of those interior angles. So I have 3 triangles this time for the 5-sided, 5-angled figure. So if there's 3 triangles, I would have to take 3 times 180 to figure out the sum of its degrees, and 3 times 180 is 540 degrees. So if I have a 5-sided figure, all 5 interior angles, the ones on the inside, have to add up to 540 degrees. Now with the hexagon, again, just going to pick a vertex, and we're going to divide it into triangles. So there's 1, 2, 3, and 4. So 4 triangles with a 6-sided figure. And for the sum of the angles, I'd have to take 4 times 180. And I get 720 degrees. So hopefully at this point we're seeing a pattern. 3 sides, 4 sides, 5 sides, 6 sides. A heptagon has 7 sides. The triangles formed went 1, 2, 3, 4. So with each time we add a side, we are adding a triangle that can be formed. So there are 5. Okay, so we take 5 times 180, and I'd get 900 degrees for a heptagon. A heptagon has 7 sides. That might be a new term. A octagon has 8 sides. So there would be 6 triangles formed if we divided it up. Might as well do this one. So there's 1 triangle, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6 triangles. So 6 times 180 is 1080. One other thing, a decagon has 10 sides. Really, you need to know these terms up through decagon. You might see a 12-sided figure, but for the most part, if you know the first 10 by name, you should be good to go, okay? N-gon means we have n number of sides. So as I look at this relationship, the difference between the number of sides and the number of triangles is 2. So the number of sides minus 2 would equal the number of triangles formed. So the sum of the interior angles would be n minus 2, which is the number of sides minus 2, times 180. So to sum it all up, the sum of the measures of the interior angles of a polygon with n number of sides is always going to be equal to n minus 2 times 180. Make sure you follow the order of operations here and do n minus 2 before you multiply by 180. All right, moving on now. We're now going to discuss regular polygons. So when we talk about regular polygons, recall a regular polygon is both equilateral and equiangular, which means that the interior angles of a regular polygon are congruent. So we can figure out the measure of one interior angle with a regular polygon. Now, this doesn't work for any hexagon or any decagon, any octagon. It only works for regular ones, okay? So a triangle has 3 sides and 3 angles. The sum of its interior angles is 180 degrees. We should know that one, all right? So the measure of one interior angle, and again, I'm going to write down here, it's regular polygon here. All right, it's not for any, it has to be regular. We take 180 divided by 3, which is 60. And the reason why divided by 3 is because there's 3 angles. If all 3 angles are the same side, 180 has to be divided evenly by the 3 angles. So for our quadrilateral, 4-sided figure, if its sum of its interior angles is 360, hopefully we know that one as well. So for me to find the angle measure of a regular quadrilateral, which is a square, we would take 360 divided by 4, which is 90 degrees. So we might have known that one too. Pentagon, 5 sides, 5 angles. Sum of its interior angles. Okay, we did that on the last page, so I'm going to write that down. The sum of its interior angles from the last page was 540 degrees. So for me to find the measure of one interior angle, I would take 540 divided by 5. And 540 divided by 5 is 108 degrees. So each angle of a regular pentagon would be 108 degrees, and these are interior angles. Hexagon, 6 sides. We said that the hexagon sum of the angles was 720. Okay, so we'd take 720 divided by 6, and 720 divided by 6 is 120 degrees. Okay, so each angle of a regular hexagon would be 120 degrees. Octagon had 8 sides. All right, if you forgot how to find the sum of the interior angles, you'd have to do 8 minus 2 times 180. And 8 minus 2 times 180 is 1080. To find each interior angle, we'd take 1080 divided by 8. And 1080 divided by 8 is, I'm using a calculator for that, 135. All right, now for an n-gon, so n number of sides. That means it has n sides and angles. For me to find the sum of its interior angles, I would have to take n minus 2 times 180. And that's going to give us a specific amount. After I find that amount, to find each interior angle, I would take 180, or whatever this is, and then divide it by the number of sides. So I would take n minus 2 times 180, and then divide it by n. Okay, so that's our next formula. The measure of an interior angle of a regular polygon with n sides is n minus 2 times 180 divided by n. Make sure you follow the order of operations. You have to do the whole top and then divide. All right, that's it for our intro for 7.1 part 1. Have a good rest of the day.